So when you guys multiply and divide radical expressions, you want to multiply and divide the like parts. So you would multiply or divide the coefficients, the numbers on the outsides, with the coefficients. So coefficients with coefficients, and then you multiply or divide the radicals with the radicals. Just combining the like parts, just doing whatever the operation is. So when you're done performing the operation, you might need to simplify the value that's left underneath the radical then. If your problem happens to have a fraction with it after you're done doing that division, a fraction is simplified as long as there's no radicals in the denominator. So let's look at a couple examples. So when you're multiplying, the coefficients get multiplied together. So 5 times negative 9 is negative 45. Square root of 3 times square root of 2 is square root of 6. Since you can't simplify the square root of 6 at all, this problem would be done and it would be simplified. So like if you look at the next multiplying problem, 3 square root 6 times 4 square root 2. Multiply the coefficients, 3 times 4, and then multiply the square roots, get 12. So what you guys need to do is simplify the 12, because I know that if you simplify that, you're going to find a perfect square or a pair inside there. So if you factor it, 4 and 3, 2 and 2, we have a perfect square of 2 inside that radical. So he will come out and get multiplied with the 12 already out there. So you end up with 24 root 3 is left. So in this case, we did do the multiplication, but we had to simplify it a little bit afterwards, so we weren't done after doing that multiplication. So let's look at some division. So 8 square root 6 over 4. So you can only divide or reduce the like parts. So you can only reduce 8 and 4 first. So 8 and 4 would reduce to 2. You could put it over 1 if you wanted to, 2 over 1. And the square root of 6, since there's no other square root down here in the bottom, it's just going to stay that square root of 6 on the top. So you can make it 2 square root 6 over 1, or you could just leave it as 2 square root 6. It would be the same thing. But there's no roots left in that denominator, so that's good. So if you look at the second one, 9 square root 12 over 6 square root 3, we have a coefficient in the top and bottom and a radical in the top and bottom. So since you have both, you should try to simplify both. So 9 and 6, you can't divide 9 by 6, but you can reduce it by 3. So 9 reduced by 3 will be 3. 6 reduced by 3 or divided by 3 will be 2. And then 12 and 3 is 4. So we need to check, do we have any square roots in the bottom of the denominator? No, but this square root of 4 can become just 2 because the square root of 4 is 2. So what happens is we actually get 3 times 2 over 2. So we actually get 6 over 2, and the whole thing ends up simplifying to just 3. So you want to do the operation with multiplying and dividing, but you always have to check at the end if it can be simplified any further. Sometimes it can't, sometimes it can. But you need to check when you have something left underneath those roots to see if they have any perfect squares in there.